Hey, this recording is for Lacey and maybe Kenzie if she wants to watch it. So this is Monday, 1.5 linear models. We are not going to get done with this because we only have like, I don't know, 20, 15 minutes left, whatever. But we're going to start it because it's the calculator part. And calculators kind of go crazy sometimes. So we're gonna do that. All right. So the first question it asks at the top: how does money spent on advertising affect sales? What effect does fertilizer have on crop yield? How much do large doses of certain vitamins lengthen life expectancy? Blah, blah, blah. All of those can be represented with a linear model, okay? Linear models, basically in this section, they're giving you a bunch of real world data. And they're saying, write me a linear equation. Now, in the real world, if we write a linear equation, not every single data point is going to fit on a straight line. But we do what's called a line of best fit, or a good line that will approximate the data. A trend line, yes, that's exactly what it is. A line of best fit that kind of approximates the general direction of all of the data so that we can plug points in and find future points, okay? So it's not going to fit exactly linearly, but it's going to be pretty close, all right? So what this is called a mathematical model. I'm going to show you how on your calculator to plug these points in and say, calculator, make me an equation, go. And it will do the problem for you. Super nice, okay? So you can also call this, you can also determine whether a line is a good model by doing the finite differences. We're going to do that in the next section. I can't make my screen any bigger than this, otherwise I'd cover up my calculator, so sorry. Example 1. So I want to determine whether or not this is a good fit for a linear model. So I'm going to do finite differences is what it's called. So I'm looking at the x values, which are years. And those need to be going up by a constant number, right? From 88 to 89 is 1, 1, 1, 1. So we're going up by 1 every year, right? Now the y coordinates, I'm going to figure out how much I'm going up or down by each time, right? So I look at my second year, 2.79, and I'm going to subtract 2.38. Okay? What is 2.79 minus 2.38? So you are adding 0.41 each time, right, to that one. Okay? Now, if I do 3.23 minus 2.79, how much am I adding there? 0.44 I'm adding. Okay, do the same thing. 3.64 minus 3.21. 0.41. Okay, last one. 4.06 minus 3.64. 0.42. Now, is that exactly the same that I'm adding every single time? No, but it's pretty darn close, right? In the real world, you'll never get every single data point to fit exactly on a line, right? But since we're adding about the same number every time, that's an arithmetic sequence, right? Which means this is a linear function, yeah? This is all tying everything together. So what we're going to do is we are going to approximate what this line is, all right? Down later, I'll show you how to do that, okay? So this one, calculate the finite differences. We did that. We said this is going to be pretty close to a linear function. All right, and then if I go ahead and plot these points, I'm going to do 1, 2, 3. 1, 2, 3, and these are going to be my years. 88, 89, 90, 91, oh, I need another one, 92. Okay, so 2.38, right about there. 2.79, right about there. 3.23, right about there. 3.64-ish, and 4. So, if I draw my line, it's going to be pretty close to probably all of those dots, but not go exactly through it because one of them kind of dips down a little bit, right? Okay? So your line will not go directly through all of those dots. It won't be completely straight, but you can draw kind of a line of this best fit, or what a trend line. Okay, trend line that kind of is close to all of those dots, okay? I'm going to show you how the calculator is going to do that here pretty soon, and Wynn's already trying to figure it out. Whatever. Okay, I'll show you how to do it. So, modeling terminology. We're not going to do this by hand, so I'm going to alter your homework assignment just ever so slightly if they ask you to do this, because we're not going to waste time trying to do this when your calculator will do it for you, okay? But I'm going to show you what the calculator does when they're trying to figure out a line of best fit, okay? So modeling terminology, when comparing actual data points to our current linear model, what they do is the calculator drops a line in there. So here's my line that the calculator is going to drop in here. And here is a dot, 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 okay? So those dots are not fitting on this straight line, right? But that's going to be the best line that's going to be awfully close to all those dots. So here's what the calculator does. It drops a line in there, and then it measures the distance from here to here, that vertical distance. It measures the distance from here to here, measures the distance from here to here, measures the distance from here to here. And it tries to put that line in there so that all of those distances are as small as possible, okay? So here's what happens. I'm going to draw this in a different color. Let's say I put the line this way instead, like a completely horizontal line, okay? Now, it's a shorter distance from here to here, but it's a longer distance from there to there. So the calculator keeps doing that over and over and over again, dropping different lines so that we try to find the average smallest distance. Does that make sense? It's trying to make it so that the distance between the vertical distance between the dot and the line is as small as it can be for each one of the dots. Does that make sense? And if I move my line, it might make one dot closer, but it will make another one farther away. So it keeps dropping those lines in there, and those are called residuals. What we're trying to do is reduce the residuals. This is a residual. You guys know the word residue? Residual? Okay? We're trying to reduce the distance from the line to the dot. Yes, sir?
Can you just find the average slope of each one?
What do you mean?
Because like on the last problem, when you were doing that.
Wait, which one is the
Like on this last one, fill out your paper. The actual trend line that you're drawing is at a 0.42 slope.
Yes. Yes. So you're saying like average each one of those two together, or each one of those four together? Okay, now that will give you your M, but which point do you use for your B?
Your beginning.
Your beginning one? We're going to do that on the next example. Okay, so keep that in mind. We're going to do that on the next example. Okay, so that's what your calculator is doing over and over and over again. There's a way to manually do it, and it is awful.
Wait, what's in the blank?
Awful.
So
Residual. Yeah, right here in the blank. Residual. 40. 40. Let's do one more. We'll do this one at the top, and then we'll stop.
So we ain't learning the fact. I'm gonna get confused.
We'll do this one at the top. Okay, and then we'll stop. Here we go. So, example 2. This is the data. Let's see what we're going up by every time. So, we're going up by 1, 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 up by 1. We're going up by 1, 0, 1, 0, 1, 2, and 0. Yeah? Okay, so we're going to try to identify a linear function for these dots, okay? We're going to try to find a linear function, okay? So, let's do this. Find two models for data. What we're going to do is, let's choose these first two right here. Let's do that. We're going to choose those first two, and I'm going to do that in blue over here. So, scenario number 1, okay? I want to write an equation that goes with those 2 points. So, my 2 points are 0, 1 and 1, 2. 0, 1, and 1, 2, okay? Now, I want to write an equation in the form of y equals mx plus b, right? To find my m, I do 2 minus 1 over 1 minus 0. So it has a slope of 1, yeah? Okay, now, y equals 1x plus b, and I want to find the b, so how do I do that? Plug one of those 2 points back in. Let's plug one in. Which one do you want to use?
Plug in 0.
The top one, of course, because it has a 0 in there, right? We're going to plug 0 in for x. 0 goes here, and 1 goes here. 1 times 0 is 0, so b is 1, and our equation is y equals 1x plus 1. Okay, now, one more scenario. Let's pick 2 different spots. Let's pick, like, the first one and the last one. Okay, let's do that. So, 0, 1, and 6, 5. That's what we're going to do. 0, 1, and 6, 5. Okay, now we need to find our slope. So, I do 5 minus 1 over 6 minus 0, which is 4 over 6, which is 2/3. Yeah? So y equals 2/3 x plus b. And how do I find b? I plug in. Which one do you want to plug in? 0, 1 or C5? 0, 1, of course. So we're going to plug 0 in here. And we're going to plug a 1 in there. So we have... Wait. I'm waiting.
Why do you have
5 minus 1 is 6 times 0.
equals 1?
Yes, you're right.
Oh.
Hey, are we good, Liddell?
Yeah.
Okay, so if I plug 0 in, 2/3 times 0 is 0, and b is 1, right? So I have the equation y equals 2/3 x plus 1. So, just by using the data that's given, I have two different equations that I could have, right? This one and this one. That's just by using 2 points, okay? I could use another combination that incorporates one of the middle pieces in there and get a third equation. So what your calculator keeps doing over time is it does this and this and this, and it goes through all of the different combinations, and then it picks which one's the best one. Does that make sense? Okay? So I got two different lines. Which one is the best one? I don't know. I'm going to show you on tomorrow how we'll have the calculator do it. So sorry we didn't get to any calculator stuff today. All right? There you go.
No homework then, right?
Well, you can do as much as you can do.
Yeehaw.